Hi everyone, welcome to Saturday Night SQL Virtual Group webinar. Happy Mother's Day. My name is Sarah Huang. I'm the founder and organizer of this virtual group. Joining me here is Debbie Huang, our co-organizer. Debbie will help post your questions to the chat window so everybody can see it. Today, Julie Cosmano will present Boost Your Analytics with Machine Learning for SQL Nerds. Julie Cosmano is a MCSE Data Platform and MCSE Business Intelligence MCT, and she's also a principal program manager at Microsoft with a bachelor's degree in IT. She has over 10 years of experience working with SQL Server for large-scale and multi-million-dollar OLTP and ETL projects as a SQL Server developer and a system analyst and designer. Julie's past projects include delivering SQL Server 2012 data warehouse and BI solutions in the US and Australia. She now works with big data projects to drive business analytics for Azure data. Julie has recently co-authored SQL Server 2017 Machine Learning Services with R. We really appreciate Julie share her knowledge with us on Mother's Day evening. Let me first take care of the housekeeping stuff, then I'll transfer screen over to Julie. We highly encourage you to attend past summit to grow your career. You'll be able to connect with a global network of over 250,000 data professionals. Past Summit is the largest conference for technical professionals who leverage the Microsoft Data Platform. You get deep dive technical sessions, learn best practices, and discover new tips and tricks.
Excuse me, Sarah. Your screen is not showing. You didn't showing your slides.
You can't see it? I'm showing.
Now okay.
Okay. Okay.
Okay. Sorry.
That's fine. So this is a past summit, and if you could attend, that'll be great. As you may know already, PASS has a career center. If you are a job hunter or if you are employer, please visit pass.org/careers to get more information. And PASS is still looking to connect with new sponsors. And if you could help, you may get a $100 gift card for any referrals leading to community sponsors. This is a PASS Summit 2018 registration offer. You'll get $150 discount by using our code, which is VGDISP9II as a member of a Saturday Night SQL Virtual Group. These are the upcoming virtual group webinars, including DBA Fundamentals, Data Architect, Cloud, and Women in Technology. They all have really great sessions. And PASS has many virtual groups in different subject areas as well as in different languages. Feel free to join as many as you like. They're all free. These are the upcoming SQL Saturday events. If if you can attend one of them, I'm sure you learn quite a bit. If you are not a past member, please join past to grow your career. The membership is 100% free, and as a member, you'll get online education content, live webinars, in-person meetups, events and conferences, and the chance to network, volunteer, and speak. These are the ways you may connect with past through Facebook, Twitter, or LinkedIn. And this is how you may ask questions during our webinar. You may either raise your hand by click this little hand sign, and either me or Debbie will unmute you. Another way to ask questions is to post your questions in that chat window. I'll read out to Julie. That's all I need to take care of the housekeeping. Now I'm gonna transfer screens over to Julie.
Thank you, Sarah. Really, it was a really lovely introduction there. Hi, everyone. Good evening or good afternoon, maybe, wherever you are. So let me just make sure that the screen is showing. Sarah, can you please confirm that you can see my screen?
Yes, I can see
the one that says for demo.
Yep.
Yep. Okay, awesome. Thank you so much. All right, so one of the reasons why I'm putting this up is because I'd like to do a bit of an interactive demo here. So if you want to participate in this little demo, you can send me an email. And so that's the email address over there. And then the subject is hashtag SQL Froyo. Make sure that it's, exactly typed in the way it is. And attach a picture like this. Don't embed it. Don't have anything on the inbox here. So we're going to have a little fun. The best kind of picture that you can do is kind of like a passport photo. It could be of yourself. It could be of any movie stars or whatever. And it will, you'll see it in a second. I'm going to kind of hold off as a surprise until then. All right. So in terms of questions, what I'm going to do is, because it's a very jam-packed information and demo type of sessions, I will pause every now and then just to ask questions, because I know in quite a few times that I've presented this, a few folks have a lot of questions. I just want to make sure that we're on time and we respect each other's time. All right, let's just get started here. All right, so I won't talk too much about myself. So this session here is Boost Your Analytics with Machine Learning for SQL Nerds. I work as a program manager in Microsoft. I actually lead the business, or help leading the business analytics team. And it's been super fun because I need to look into quite a lot of aspects of business analytics, including, in some cases, some of the data science sort of areas that we can explore into. So I started with just, play around with R and see how, we can potentially use more of data science to help with business analytics. So that's a bit of background about me. I'm on Twitter as well, in case you want to ping me, or you can contact me as well if you have any more questions about this session, or anything about business analytics in general. So I also had a great opportunity to partner up with Thomas Castron, one of the leading person in terms of SQL Server and R space. He's based in Slovenia. So we wrote this book together. We had a lot of fun writing this, and it has a lot of information about how to integrate R inside SQL Server and how to operationalize it, and things that you want to consider, including performance, how to do change control or change management, and some of the more technical sort of R aspect about predictive analytics. And I think there is a discount right now with the pack publisher. So if you want to search for this book online, or go to that URL over there. All right, so I have 4 main topics here that I want to cover. Firstly is why machine learning, how to operationalize machine learning in terms of SQL Server and R, some of the tips and tricks in using SQL Server and R, and then some of the useful resources that you can find out about SQL Server and R as well. All right, so why machine learning? So this is actually a little bit of a personal story, just because I think sometimes it's a good idea to bring in, some real life story into some of these topics. So as a product manager or program manager in large companies, in most cases, what we have to face day to day is thinking about how to delight customers, how to make sure that the business, continue generating revenue essentially. So either coming up with innovative products or services, or delighting customers. So that's kind of one of the reasons why machine learning is actually, or even data science projects as well, have made it really big in the industry today. So if you are coming from the operationalization side of things, especially, I know that my role in the past was in the kind of database development, data warehouse, and BI for operationalized kind of work. In most cases, you'll see a lot of the data science work or the machine learning would be applicable into the automation side of it, and as DBAs, if you are a DBA. You can definitely take advantage of this. And in fact, if you go to the Thomas Gustron's website, he has a lot of examples where R can be very useful in terms of doing a bit of a kind of to do some of the DBA work in terms of predicting and seeing patterns and all that. So I would encourage you going to his website there. All right, so let's look into operationalizing machine learning. So before I dive into that, I want to talk a little bit about R. One of the reasons why R is kind of my favorite language besides T-SQL. I've learned quite a few languages over the past few years, and R is actually one of my favorite ones because it is very applicable, or it's very easy to use. Especially if you're coming from the analytics or analyst background. It makes it easier to understand data. So it's super easy to, for example, just type in like a summary of the variable, etc. It will tell you the distribution of the variable or the data set that it holds. So it's super useful, and on top of that, it's open source, and there's a lot of people in the community. So one of the websites that I want to recommend, besides the one that I mentioned about Thomas Castron's website, is actually R bloggers. So it talks about a few things. So for example, I think David Smith's also talking about how Excel is actually bringing in Power BI charts, and because Power BI has our component in it, so it can be brought into Excel. So that's actually pretty cool. So it is very up to date, and lots of authors, very well-known authors and experienced authors are contributing to that blog. So our bloggers is another one to go to. So if you're coming from SQL Server background, and a lot of the things that you've done is maybe database development or DBA work or data warehouse and BI, a couple of things that I want to talk about here just briefly is to make sure that everyone sort of understands the basic of how do you do like the essential data science project or predictive modeling steps. So in R in general, what you'll start is, especially if you want to do prediction, you typically retrieve data set from somewhere, some sort of data source. And then after that, you do data cleansing, maybe transforming a little bit. So it's a little bit of kind of like an ETL-ish process there. And then once you do that, you figure out what are the best features. So essentially, what should we use to input into the training model or to train a model. And then afterwards, once you're happy with it, you're happy with the accuracy, then you kind of operationalize it and, make a kind of like a predictive model there, and then you use it for prediction. So, and a lot of the time, what I consider as the iterative process is between the retrieving the data set all the way to the training. And sometimes even once it goes to the production here, you have to go back again because maybe the accuracy is not good enough. Maybe there's some sort of changes into the features or variables. Then you have to, continuously improve it. And that's kind of one of the reasons why in the book that I wrote, I focused quite a bit on the change management side of it, because I believe that although it becomes easy now with R, that you can execute R inside SQL Server, there is a lot of advantage of beyond just executing it part of the database as its own or as itself, but you can integrate it better and make your training model sometimes better with the ability of doing a kind of like an automated builds and change management side of things. So I'm going to pause for a little bit here just in case there are any questions.
We don't have any questions so far.
Okay, sounds good. All right, so before I go too much further, let me show you RTVS in Visual Studio 2017. Some of you who are familiar with R already, you may be familiar with RStudio, and I would recommend keep using that. If you are working with database projects already, so for example, you have a database project inside Visual Studio or SSDT, then I would recommend trying out RTVS because it makes kind of easier. You have this one environment, one IDE to do a lot of your work, so you don't have to jump in and out to different IDEs. So in some cases, RStudio is a bit more mature, but I think RTVS has got quite a lot of nifty features as well. So I'm going to show you some scripts here, some R scripts here. Now, this session, I specifically wrote it just so that for the audience who are familiar with R, basic R, or if you are more advanced, so this session might be a little bit slow. So I'm hoping that some of you out there who are advanced can be a little bit patient here. All right, so this is a typical example of an R script. So I'm loading some packages so that I can call some of the functions. And then when I call a variable like this, empty cars, it actually holds a data set. I think this is if I remember correctly, it's a data frame, data type. Then I can assign a variable. So this A here, empty cars. So I'm assigning the value of empty cars to A. Then if I type in summary A, then it gives me let me dock this again. Then it gives me the summary, the statistical summary of that data set here. So, and then I can go to the next one, which is the plot function. So what I'm doing here is I'm just plotting the relationship between all the features to one another, sort of like a bit like a correlation sort of relationship here. So of course it's really hard to see. And then if I go to the next one here, I'm actually drawing a correlation plot between all the features. So if you're new to predictive modeling, I would recommend you taking John Hopkins Coursera course. actually there's a data science capstone project, capstone sort of course where you want, where it I think consists of about 10 courses. There is one specifically on the R programming side of it, and then there's one into practical machine learning, and that's actually super useful. It's quite heavy on the mathematical side as well, which is good if you're hungry on the mathematical side. So when I want to do some predictive analysis, usually I need to come up with the output that I'm after, as well as the input or the input parameters. So sort of like saying a formula, right? So to know what input that I need to put into creating a model, I need to know what features should I use. Technically speaking, I can just throw in all the features or the input variables that I could possibly have, but that's not good because the results in the feature can be very skewed. And then on top of that, sometimes it will also take a long time to generate the model. So one of the ways that I usually try to understand about my data set is beyond running summary A here just to understand the distribution of the data. I also look at things like correlation plot here. So obviously MPG is highly correlated to MPG, so that's not a surprise. Whereas MPG and cylinder here is kind of inversely correlated. Well, it is correlated, but the opposite way. So the higher the cylinder, the lower the MPG. And then if you look at the blue one here, so this is the scale, blue to all the way to red. So if I look at the deeper blue here, so the cylinder here is highly correlated to DISP here, or horsepower here. So now I can get to, I can choose, okay, so these two may be, so assuming that my output is MPG, so that's what I want to predict, I can probably choose something like cylinder and maybe this, but I'm not quite sure here. So it's something to sort of think about. Maybe they're too similar that I might just want to choose one of them. And then maybe the DRAT here or the VS and so on. So I can sort of start narrowing it down to just maybe 2 or 3 to play around with until I'm satisfied with the accuracy. So I'm going to stop there and continue. I'm going to stop there from the perspective of talking about predictive analysis. So I'm going to just continue to talk a little bit more on the basic of R. So if I want to draw different sort of plot, then I can do this. So this is also another way of exploring your data before doing predictive analysis, which is, okay, I'm just going to plot all the relationship between petal width and sepal width for the different species. So this is actually to do with a different data set, iris data set that I'm using here. And then so I can clearly see like there is a, clusters. It looks like there's sort of obvious clusters here. And I can maybe use this as a way of identifying whether species can be identified based on sepal width and petal width. All right, so, and then I can also create a function. So this is kind of my own function like this. And then if I want to call it from another script, I can just, call it like this, my iris summary iris. Then I can right click on it. Let me, oops. I can right click on it and then say pick definition to see what was it that I defined earlier. So RTVS has got this kind of niceness about it that it can make it easier to see the definitions of the functions. Now I'm going to switch back to something a little bit more relevant to what I showed you earlier here. So I was talking about this iterative process of predictive modeling steps, right? So this is what my typical way of running or coming up with or training a model. By and large, most people do it this way. But maybe you have your own method, but this is kind of the way I do it. So I want to load the RefoScale R library, just because RefoScale R is actually better in terms of performance perspective, and then I'm connecting to my database that I have locally, set up locally. Then I'm just gonna set the compute context for SQL Server, and then I'm actually getting the data, essentially importing the data into R. So when I do this, R is actually storing all of the data set in memory. So at the moment, I'm running it against my laptop, which is fairly not as beefy as my desktop. I think it only has about 8 gig of RAM, which is not much at all. So I want to be careful with how much data I can throw into my R script here. So that's why I'm doing the top 1000 here. And then I would use the RX logit, so the logistic regression model, to actually do to create my first model. So in this case, what happens with the data set here is that I've got a data set that contains age, gender, and the emotion, and whether or not they're likely to buy toppings on the on the frozen yogurt. If you remember at the beginning, I have my demo slide that says SQL for you. So that's exactly what we're going to do here. We are going to predict the likelihood of a customer buying toppings on frozen yogurt. So that's my my shop right there. my not real shop, but it's for the demo. Okay, so what I've done here is I've come up with a model, and I store it as logit model here. And then I'm looking at the p-value here. Is actually not too bad. The p-value here, oops, this one here, this last column, which is not too bad. And then what I do is I'm looking at it, okay, let's see if I can start evaluating the model. So the next step is I'm just trying to do the prediction based on the model that I've created. So I'm going fairly fast on this because I kind of want you to get a bit of a flavor of what I'm doing, so that you can research on your own as well. So the next thing that I'm doing here is trying to draw the ROC curve or the AUC curve to see how well my model is working and if I'm satisfied. Anything that is above 0.5, generally I'm happy. 0.5 is kind of like a bit of a coin toss type thing. It's not that great. But if I could get 0.7, 0.75, usually it's pretty good. But we'll see. Let's start plotting it. Let's see. Let's just plot this. Okay, so that's my ROC, which is the blue line here, and it's looks like it's working better than just the diagonal line, right? It's the higher it goes, like as close to this corner, to the left top corner, the better it is. And I'm looking at AUC of 0.83, which is reasonably good, so I'm quite happy with it. Assuming that I'm not happy with this, then I would go back all the way to the top and then perhaps change some of the variables and then change some of these function, essentially. Not function, but more like a formula, essentially. And then do all over again until I'm happy with the AUC value. So because I'm happy with it, then I'm just gonna stop here. Now I can continue. I think I'm up to here. I'm just gonna continue the rest of it really quick. I think I don't have to execute all of them. I think this will create really nice plot. And then I'm gonna jump all the way to the bottom here to serialize the, to put the model into SQL Server. So if I have a siloed data scientist who works on sort of their own environment and they are actually actively developing on the model, this is likely what they do. They're happy, they've come up with the model, and the last step that they would do would be entering this into SQL Server. So as part of the operationalizing it inside SQL Server. Now I'm gonna switch to the slide again and then ask if there is any question.
Hey, Julie, I have a couple of quick questions.
Okay.
Would you be able to share the code then?
Yeah, I'll be able to share the code. Yeah, I'll do that.
Okay, wonderful.
Yeah.
Well, earlier you mentioned that it's running in memory. So if you have a large amount of data, would you be able to run it on your laptop?
So with a lot of the, assuming that the question is related to just predictive modeling, in some cases it can be very tricky. I have worked with a data scientist before a couple of years back, and he was using it, he was running it against like his kind of sort of not so beefy environment, and he ended up running in the model for like days. So it does happen. So here's the trick. What I have learned since then is in R, I cannot remember the function now. In R, there's a way of separating the trainings data set from the test data set from the same kind of pool of data, essentially, maybe from the same table as an example. And then what you want to do is maybe take a smaller in random, just maybe like a smaller set that hopefully, because it's picked in by random, it will be representative of the population. So I would start with that, especially if you're running it in just your own environment. And there are ways that you can make it a bit more scalable when you use SQL Server, and I will show you in a minute.
Okay. Maybe I missed this. You were using Visual Studio 2017 or TVS. Is that free?
So the community, so Visual Studio now comes in, I think, 3 different editions. One is community, and then professional and enterprise. If I remember correctly, you can get community edition, which is free, and RTVS also you can install as part of it. So it's fine. So you can use the community edition.
Okay, cool. Thank you. That's all I have.
All right, awesome, thanks. So I'm gonna continue with a few of the slides before I go back to the demo again. So some of the challenges of using R, so you saw earlier with my R script, right? I'm actually moving the data from SQL Server all the way to R in memory so that I can do the predictive analysis. Once I do that, I have this model that sits somewhere, which is in my R environment today. And as soon as I close and stop my laptop and all that stuff, if I don't store this model, this kind of binary format of the model, then that's it, it's gone, which is not good. So there needs to be a way of storing that model somewhere. And then, so if I have an application developer, then I have to somehow transport this model and give it to the application developer and ask, hey, can you operationalize it somewhere in your C# environment, etc., which is maybe not so easy if you're not familiar with how to do that in R and C# as an example, or in the application. And then on top of that, I mentioned about the skill and performance too, like my laptop with 8 gig. Not sure whether it's going to do that well if this is to be productionalized. So that's some of the challenges. So in pre-2016, this is exactly what happens, and that's exactly what I was doing earlier, where I have SQL Server, and then my analytics server here is actually just my laptop, and I'm pushing the data here, and then I have some model that needs to sit somewhere, maybe in SQL Server, maybe somewhere else, maybe it's inside the application itself, or this scoring sort of server somewhere, not sure, or scoring module here. And then the applications, when it actually fetches some data from SQL Server for some sort of transaction workload, then it has to do the prediction, then it will probably likely have to go to the scoring sort of area, like a service, and then put it back to the application somehow. So like these predictions here. So essentially, it is very messy. So live before SQL Server 2016 to do this is reasonably messy like this. And on top of that, if you live like in Seattle or Portland, traffic is getting a bit of a nightmare these days. So on top of the messiness, there's also bandwidth issue. Like how much can you transfer to your laptop when you do development and productionizing it, and then how much can you put it back to the production environment as an example. Like you might have this bandwidth issue. So it gets us thinking, and Microsoft was thinking the right way, especially with SQL Server 2016, with their in terms of extending SQL Server to work with other languages better. So what the concept is that a lot of the intelligence regarding the data at the moment, or not at the moment, but before SQL Server 2016, a lot of the intelligence here is stored with the application and not with the database. What we're proposing here is with SQL Server 2016 and above is where the intelligence about the data should really live in the database area rather than the application, so that folks who deeply working with the data can make changes a little bit easier, and it doesn't have to touch the application. Especially if you have different sort of application people working differently from the data people. This model here makes sense. So with SQL Server R Services, that's the SQL Server 2016 version, or in SQL Server 2017, it's called SQL Server Machine Learning Services. So they're still the same thing in terms of the R, except in 2017, it is called ML services because you can use R as well as Python if you decide to use Python. The goal is that it will help you reduce or eliminate data movement with the in-database analytics, or with the in-database R. And then you can deploy R scripts and model much more easily, especially when you do the prediction side of it. You can wrap the prediction as part of T-SQL work, as in T-SQL stored procedure as an example, and you don't have to change the application at all. And then you can also do you can also achieve enterprise scale and performance, because in SQL Server, remember that we have the in-memory and column store indexes together with the RefoScale R library. It actually works quite well in terms of helping you scale. So a lot of the data, kind of like the filtering, maybe some of the data cleansing if it's possible, you do that inside SQL Server, especially the filtering side, and to reduce as much as possible the data going into R. Do that outside of do that as part of SQL Server work, and then you can pull that data into R with the SP execute external script. So essentially, your workflow as a database developer or data scientist who are working with R and SQL Server is you can develop and explore and experiment in your favorite R IDE. So for example, RTVS that I showed you earlier. So that would still, I would still do it that way, because it's just a little bit easier to exploit data, especially if it's maybe a smaller set of data. And then you do the training. I would tend to do some of the training just to begin with in our RTPS or RStudio. Then I would train it. Once I'm kind of reasonably happy with it, I would train it inside SQL Server and call SP execute external script, and then save the model in the database. When I want to deploy the model, then I would also call the SP execute external script if I'm using 2016 to actually do the prediction. If I'm using 2017, there is a new function, predict. So if you have a separate person, like a data scientist who does some of the predictive modeling, and you're actually only in charge of the database development, you don't have to know much about SP execute external script. In fact, you can just use predict function to do the prediction really easily. And then your apps is just simply consuming whatever that the stored procedure wrapper that you have inside SQL Server, and that's it. Like if you change your model, the application is abstracted away from it. If you decide to come up with a new model or come up with a new kind of prediction, the application wouldn't get touched. So essentially what we're saying here is that I love clean kitchen. So SQL Server 2016 is really allowing me, really allowing me to get that, cleanliness, and it's super easy. So I'm just gonna pause briefly and ask if there's any question.
Yeah, Michael here asks if you know how to deploy R scripts and models in Oracle database server.
Ooh, that one is a challenging one. I'm actually not familiar with Oracle. It's been more than a decade since I used Oracle, so I can't help you with that. I'm sorry.
Maybe Mike can Google it.
Any other questions?
I think that's what we got so far.
Okay. All right. So I'm going to pause at the clean kitchen side of things, and I'm going to go back to at the demo here. So let's see. I should really connect to my server here. Okay, so one of the things, so what I'm showing you here is SQL Operations Studio. In case you're not familiar with it, this is a new IDE, essentially, kind of like a lightweight, I would kind of call it lightweight version of SSMS. I still use SSMS, but there are times where I find SQL Ops Studio really, really useful. So I talked quite a bit about R in terms of its capability in prediction, or to come up with a prediction model. So what I'm going to show you right now is using R from data exploratory perspective. So I'm going to connect to White World Importers. And then what I'm going to do here is to show you how to call SB execute external script to draw a chart to help you understand about the data that you're going to be working with. So as an example here, I'm actually calling a SQL R script here. It's kind of like just a kind of, can treat it as a dynamic SQL sort of. And then, so the first part here is to get the data set that I want to put into SQL execute external script as a data set that I want to work with. And then the next one here is I want to define the R script. And you notice that I'm referring to things like input data set. So this is kind of like a keyword to represent the input data set that I will pass into. And the plan is to pass this into as the input data set, this value here. And then the output data set is the outcome that I want to return from the SB execute external script. And in this case, it's just kind of like a kind of binary value that represents the image. So what I'm trying to do here is actually to do to get the monthly order count and order amount by per salesperson in the year of 2015. That's why I'm doing the filtering here. Remember, I say that, do lots of your filtering outside of the R side of things. This is what I mean. Like, I'm doing the filtering here. I'm joining it here instead of inside of R. Obviously, you can do that too, but I find it a lot easier to do it here outside of the R side of things. So then my SB execute external script will say that I want to run the script, and the script is in R language, and the script that I want to execute is this R script here. And then this R script, I'm saying that it will have input data set, and the input data set will actually be represented by this dynamic script as SQL script. So this data set here, when we run SB execute external script, will be executed at runtime and then pushed to SB execute external script, so pushed to the R server side, and it will do the calculation, and then it will give me a binary representation of the plot that I want to do. So if you run this in SSMS, this is what you would get, and that's about it. But if you run this in Ops Studio, you can go to this View as Chart on the right. So this really tiny icon here, this part here. So I'm going to click on that, and then it gives me this chart viewer, and then I can change chart type to image. So now I've got a plot that are produced for me to see what the relationship between the order count and the total amount, so that's the total amount in dollars, the monthly one by the monthly values by salesperson. So I can see that clearly from visualization perspective that Hudson is kind of like the top performer. He gets a lot of orders and he gets a lot of sales amount value, so he's a top performer here. So that's kind of one way of using R inside SQL to do data exploratory. Now, what I'm going to show you next, so let me just go back to the slide here. Where are we up to? Okay. All right, so I'm going to show you the prediction or the predictive side of it. So let's see the train like toppings here. Now remember this script here. So I still have to, well, I prefer to do this in some sort of RIDE so that I can quickly check my model and just work iteratively. Once I'm reasonably happy, right? And once I'm reasonably happy, maybe my first one, my first model that I've got, I want to bring this part. So the part that I'm actually creating a model into, actually it's only this part here, into SQL Server. So the way I do it is I can create a stored procedure, so USP train like toppings. So what I'm doing is I'm bringing the data, which is the top 1000. So that's very similar to what I've done at the top here to get the data. It's like top 1000. And then what I'm doing next is I'm actually executing a small script and I'm calling R, and I see how I'm just essentially copying that similar line, which is, create me the logistic regression model. The next step here is I'm actually serializing the model, and then I'm actually outputting. I'm really interested in the AUC score or AUC value of the model that I've created. So so from my really, really long scripts, I extracted the things that I need, which is creating a model. I want to find out the AUC, and then I convert it into this stored procedure. Now the process here, remember, I'm not just copying Control A and then Control C here. It wouldn't work. It won't work well, and it wouldn't be performant either. So it's best not to do that. And then once I'm happy with the AUC, not happy with the AUC. Actually, what I wanted to say is once I execute the SB execute external script here, I've got my model and I've got my AUC, and I just want to insert it into a table here that holds my Fourier model. So this part where it is inserting into the Fourier model, technically I could also have just execute this part here. So this last step here is the same as this last step here. So I can store the model from R itself, or I can store it as part of my USB train like toppings. So that's so there are two options there in terms of coming up with a model. I'm gonna pause for a second in case there are any questions.
E has a couple of questions. E, I have unmuted you. Go ahead and ask your questions.
Okay, thank you. The first one, is this SQL Operational Studio is a new version of the Management Studio?
It's not a new version of SMS. It's a separate tool. But it's meant to be nothing intended for database developers as well as DevOps. It's based on VS Code. It's very lightweight. I believe it runs in multiple OSs.
Okay. Also, so what is the difference to run the R or machine learning at SQL Server versus on Azure environment, cloud environment? Yeah.
When you say Azure environment, are you talking about Azure ML or are you talking about Azure SQL DB? or sorry, Azure SQL VM?
It just basically I'm asking which is run that in the cloud environment.
So
Is it more powerful over there? Like you can deal with much larger data set?
so there is so there are a couple of I may be slightly out of date on this, but from what I can understand, there are a couple of things that you can do on Azure today. So you can use Azure ML, do your prediction model there, and create kind of like an API to do the prediction. To call the predictive model that you've created. So there is Azure ML that you can use. It is good because if you have application out there that's running as a kind of like a web service anyway, maybe that's easier than setting up your own like on-prem server to just do predictive analysis. So there's that. It's a bit hard to beat cloud service solutions if you're already on the cloud. So it really depends on your architecture. There's also so if you go to the Azure portal, there's also, I believe, a data science specific VM that has been created that allows you to do quite a few things that I've mentioned to you. If I remember correctly, it's just an Azure VM with a lot of with the preloaded R server and SQL Server.
Oh, I see. Okay, thank you.
Yep, no worries. All right, time flies. So I've got 10 minutes. So I'm going to breeze through this slides. All right, so what we're going to do here is that in SQL Server, we want to do the model training like I've shown you earlier, or we can also do the scoring. So from the scoring perspective, I'll show you in a second. Once I have the model stored in SQL Server, all the predictions just go to the applications. So what that means is, so I've got things like this. Okay, so this is a stored procedure where I do the prediction. So instead of the application calling or doing all of the lines of codes like this, you can wrap the prediction model call with just a stored procedure wrapper like this that you can create. So what this does is it's just saying that, hey, I'm going to put age, gender, and emotion, and then push that into R with the model that I've already created before. That's why I'm doing the select top one model. So I'm just kind of picking in random, not in specific order. And then in case I have multiple models here. And then what I'm doing is just unserialize the model. I have to do that because the way the data is stored is serialized. So I have to unserialize it first and then put it in use in R by using the RX predict function, and then it will give me a value. So essentially your application would simply do this. So let me just make the screen a little bit bigger. So yep, so this is all good. And this gives you an example of the model that I have stored. So I've created multiple ones, and then the 8.825 seems to be the highest. And then in SQL Server 2016, so if I didn't put it in a wrapper, then I have to obviously run a few lines of code. But if I put it in like a stored procedure wrapper here, I could simply just run it like this. So for a female age 32 with a fairly ecstatic mood, the likelihood of buying topping is 85.4%. And then if I was running this against SQL Server 2017, which happens to be my server here, notice how easy it is for me to do the prediction. So before I have to run all these long scripts. Over here, I don't have to do any of that. All I'm doing here is just calling the predict function. So I'm getting the latest model, and then I'm just pushing the value that I want to predict, or the input values that I want to predict. And then it gives me the information. Not only it's faster when you use the native scoring, it's also easier for the database developer to call. And obviously, you can abstract this out from the application. It doesn't need to know whether it's using predict or SQL execute external script like this. So yeah, it's just a little bit simpler for the application developers. All right, now the demo side of it. Let's see. So this is a Power App that I've created, and let's see. So this is a Power App application that I've created, and it simply takes the photos that you have sent me from the email, and then it will push it to my SQL Server instance, and then it would do the prediction modeling. So the cool thing about this is that I was planning to do this in R, but I thought it might be a bit complicated. So I decided to call Cognitive Services API. And so from the photo that you've given me, it actually goes to calls the Cognitive Services API to predict the gender. And then it will also predict the age. And then it will also predict the emotion. And then it will give me the likelihood of buying froyo. Buying toppings for the frozen yogurt. So I've got this me, Shirley Temple, Mr. Bean. It looks like someone sent an email with the photo. So age 36. So that's cool. So that means the demo is working, which is awesome. And then let me see. Let me just do a quick cheat of what I have prepared earlier. Sorry. Since we're running out of time. So let's see. Let's see if it would work. Just click leave. For some reason, today Power App seems to be going to the back and forth preview mode. Maybe I wasn't setting this up properly earlier. Anyway, so let me just go back to the slide deck since we only have 4 minutes left. But so yeah, so that's kind of like an example of doing the prediction modeling for the SQL frozen yogurt or SQL froyo. So I've shown you a couple of things earlier just to sort of wrap it up a little bit. So I've shown you where I'm using SQL execute external script, and then I did very little of data munging side of it, but I did show you how to do the training model and how to persist it. And I did show you as well how to do how to execute SQL execute external script to do data visualization. So it's fairly powerful. It's actually really good. And this is the frozen yogurt demo that I've shown you. So I think this was me back a few years ago, Mr. Bean, and then Shirley Temple, 96%. And then just quickly to wrap it up, what happened earlier was that when you send me an email, that email, I actually called Microsoft Flow to push the image and call the cognitive services using CLR here, do the model training, to do the scoring, and then to do the predictions here. The actual model training side of this, I actually did it earlier with a few sample data sets that I have done. So operationalization is everything outside the red circle. So some of tips and tricks here is that when you install SQL Server 2016, there is this option of R Services, and make sure that you check that box and continue during the setup. If you're using SQL Server 2017, make sure that you use the machine learning services here, and then there's the R and Python option. You can install R and not the Python side. And then there is this SSMS custom report. So I'm going to make this slide deck available on my website, mssqlgirl.com. And here from the SSMS custom reports, after you install SQL Server, there are a couple of things that you need to do. And I find it a lot easier to set it up properly using SSMS custom reports and then click this view SQL script and then just execute it. It allows a couple of checks and then enable the implied authentication and whatnot for you on your behalf. So thinking about R, the future or the way you think about how SQL Server has positioned a couple of this extension is from what we call extensibility framework. Essentially, R extension in SQL Server, it's super awesome, but it's when you think about it, it's not quite a new thing that SQL Server had done. It just pushes that extra, it just gains that kind of extra capability. But when you think about it, CLR has been around for quite some time, and that's probably, I would say, one of the first kind of really useful extension that SQL Server had done. A couple of things that you can do is, govern the resources using Resource Governor. And I think we talked about this. I'm going to breeze through these. Native scoring can be done on the RX models. Just make sure that you use this. This is my recommendation. If there's a way to take away, just use the RX models. The RX functions whenever you can. Some of the do's and don'ts, develop and test in IDE, and then model management in database. So this is where you store the model inside SQL Server. And then some of the don'ts is, make sure that you don't do anything silly like embedding secrets in the scripts, especially if you call things like cognitive services, and then don't run the R and Python script as is. You need to make sure that you leverage the best of the language, T-SQL and R or Python. Just make sure you use the right tool as well. So if T-SQL is good for the ETL and cleansing and filtering, use that. Don't use R. If R is good on the visualization and predictive modeling, then use R. Don't use T-SQL for that. So make sure that you know your tools well. So I'm going to pause here because this has a lot of useful resources. While I take any more questions and before we end the session.
Oh, hi, Julia. If you have a little bit more time, we can extend this. And there are a couple of questions. The first one is that can R in SQL be used to analyze image data? I guess it's yes, right?
Yeah, I think it's just depending on what library you're using. I personally haven't tried it or haven't had the need to do things as such, but you can always try to, sorry, let me just escape this. You can always try going to online and search, and like I mentioned, the R bloggers is super useful. And then maybe just check out Thomas's website because he may have some discussions around it too. Yep.
Oh, so another one is can you share the code? I guess we asked this earlier. You share the code, right?
Yeah, I will do my best in terms of sharing. So I might put it on GitHub, and if I do, I will either put it on my website, mysqlgirl.com, because a few people have asked already as well.
Right. I have. Well, we have a website. I can also post it on our website if that's possible. If
Yeah,
you can email me. Yeah, email me. I'm not sure why this one says I did print screen here. It is for you. Well, let me unmute.
No, Sarah, I think she's talking about the Julie's email address.
Oh, okay. I got it. All right, never mind then.
Yep.
Well, yeah, earlier you mentioned that when during the tips you said for the 2017 you can choose either R or Python, or you can choose both. Can you choose both in R and Python for installation? Okay.
Yeah, you can choose both. Yeah.
Okay. Another thing is that you mentioned about storing your model somewhere before you lose that. But would you be able to share a little bit, elaborate a little bit more about that?
Yeah, sure. So let's go back to this script. So assuming that you're using R, I'm actually not sure how you would store it if you weren't storing it in SQL Server. I think there is a way in R where you can store the model in some ways. It's just that I haven't done it. I haven't had the need to do it because I either have the model that I just create it and then run it, or I store it in SQL Server because predominantly my data source is SQL Server, so that's what I've done. So essentially the steps looks like this. So once I've got the model, so we just in logit model, I'm serializing it. This one here is just making sure that everything, this one is just sort of a part of the serializing it. And then I'm calling the RODBC and connecting to my SQL server that I have defined early on the top. And then I have this execute USP persist model, which actually stores the model into SQL Server. And so essentially I'm executing a start procedure. So let me just go to my SQL Ops Studio. So when I'm persisting, it's essentially just, I'm getting the model from R. So that's the input parameter that R will provide. And then I just store it in the table like this. So you can just store the model, but I tend to like inserting some sort of description, and then I put the real-time scoring, whether I'm using real-time scoring or not, and then I'm using AUC. I'm storing the AUC value as well, so that I can compare over time. So that's if it's from R. If it's from if you once you're happy with the model and then you jump straight away to the T-SQL to create the start procedure, and you do all this, then the AUC, sorry, the model is an output variable, which is, so this model here is an output variable, which is coming from this here. And then the AUC also output variable, which is coming from this. That's it. And then I'm inserting it into for your model here, which is similar to what I just done in the other start proc.
So if you save the model in SQL, anybody else can access it, or
Yeah, well, it depends on how you secure your table. So once you put it in SQL Server, then it's just like any data in a table. If you secure it in a certain way, then nobody else can access it.
Gotcha.
So it's just managing like a normal table or rows.
Okay. Another question is, where do you clean the data, in R or somewhere else?
It depends. In most cases, I would try to clean it as much as possible in SQL, just because it's usually a lot faster. But if I'm still exploring, pivoting here and there, and if the data set is still small enough, so for example, I'm just working with 100 rows of data, then it really depends what I'm comfortable with. So every now and then, I find that R is a bit easier to transform data, like for example, like pivoting things around and do a quick aggregation and all that. This is while I'm exploring, then I might use R. But once I hit the production or trying to productionize this, usually I think about how do I structure it in such a way in SQL so that when it hits R, the data is already ready to go and I'm just using R for prediction or doing data visualization.
Cool. Thank you so much. I think that's all the questions we got so far.
Okay, awesome. Thank you guys. So I really appreciate having you attending this session. It's been super awesome. And just kind of one last shout out, if in case you're interested in learning more about machine learning services with R. There's this book. Currently, it's on sale, only $22, so $22.40 plus tax and whatnot.
Yeah,
Thank
that's Julie's book. It looks pretty nice. Thank you so much, Julie, to share all the information, and I think I learned quite a bit. And this session is recorded, and I will post it on our YouTube channel probably tomorrow. And Julie, you also share the code and the slides with me, right? So I can post it on our website.
Yeah, the slides should be available somewhere on my website, if I remember correctly. The code I haven't made available. I've been a little bit lazy. So, but yeah, I'll do that as soon as I can.
Okay, wonderful. Thank you. Thank you so much,
Thank you.
Julie.
All
Thank
right,
you,
thanks for having
everybody.
me.
Yeah,
you,
thank you.
Sarah. Bye.
Bye. Thank you, everybody, for attending. We'll see you in our next session.
See ya.
See you. Bye, everybody.